Okay, this is Mrs. Halley, and we are looking at 8th grade lesson 5.2, comparing functions. The goal for today is I can compare the components between two functions. Now, components just means the parts. So we're going to be comparing parts of two functions. Now, the main thing we're going to be comparing is slope. So I want to spend some time reviewing slope. We will have one part where we review the y-intercept. I'll spend a little bit before you answer that question. But just so you remember, slope is rate of change. If you hear someone say rate of change or problem asks for the rate of change, they're also talking about their slope. Now, in the equations, y equals mx plus b, slope is the m, the number multiplied by x. If I want to find it given a set of two coordinates or 2 points from a table, I do y2 minus y1 over x2 minus x1. So I know you remember doing that with the coordinates, and you had to get 3 in a row correct, and you really hated me as we were working on that. We also have rise over run. So I go up 2 over 1, 2, 3. My slope is 2/3. So we are going to look at 3 examples where we are comparing two different rates of change. And I tried to get fancy and animate this. Just go with me on this. It's going to blank out for a second. It's okay. So here I have which has the greater rate of change. So I have the equation y equals 3x minus 5. And I also have a graph. Now, in this case, you notice it's not in the same format. I have one equation and one graph. For each of these, I need to find the rate of change. And if you remember, rate of change, it's the same thing as slope. So I go through. Y equals mx plus b. M, the number multiplied by x, is 3. So here, m equals 3. Okay, there we go. Okay, on the next one, rise over run. So rise 1, 2, 3, 4, run 1, 2, 3. My slope is 4 over 3. The greater, the bigger one, 3 compared to 4/3. 4/3, that's the same as 1 and 1/3. This is the greater rate of change. So y equals 3x minus 5 has the greater rate of change. Okay. Here's my next one. Again, go with me on this. I'm trying something different. I'm not sure if it's going to work or not. So here, which has the greater slope? Again, slope, rate of change, same thing. So we've got a line that goes through the points 2, 5, and 6, 9. Or I have an input-output table with my x values and my y values. Now, on this one, we're going to have to do that thing that you hated. So I have y2 minus y1, so the y coordinates, those are 9 and 5. And if you want to put those on a data table, remember we just made a line, x, y, and we just listed 2, 5, 6, 9. So I take 9 minus 5 over 6 minus 2. This gives me 4 over 4, or 1. On this one, 11 minus 7 over 3 minus 1. And remember, you could pick any 2 points. I just picked the first 2 that were listed. This gives me 4 over 2. The slope is 2. The greater slope, it's my table. And so now we're going to look at example number 3. So this is asking which has the greater y-intercept. Now, y-intercept, remember, is the point where it crosses the y-axis. If I have a graph, it's really easy to find. If I have an equation, really easy to find. If I have a table, not so much. It's where it crosses the y-axis or where x equals 0. Now, I'm not told what it is here, but I can figure it out because this is a linear function. So I can find my slope, 10 minus 2 over 3 minus 1. This gives me a change of 8 over 2. My slope is 4. So for every 1 it goes up, on the x, y changes by 4. Well, that tells me if I go back 1 here, I'm going to go back 4 here. B is negative 2 here. That's really tricky. I don't think you're going to have to do anything that tricky, but I did want to show it to you. Now over here, it's really easy. Y equals mx plus b. B is 4. So I have negative 2, positive 4, the greater y-intercept. It is function b. Now we will work on this together, and it's hopefully a lot of review, and the only difference is now we're just comparing two different functions as opposed to just looking at one.